Unit 7 is going to be about properties of exponents. You've seen many of these in the past. Uh, the first rule we're going to talk about is the product of powers, where you have two powers multiplying by each other. Their exponents are going to be added, and that's because x to the a is talking about how many times x is there being multiplied. X is being multiplied out a times. And when you write out this, we don't know how many times it is. This is here a times is being multiplied by xb times. Together, all of these times is a plus b times of x times itself. Then for the quotient of powers, we have something similar, but instead, we're in a fraction. And when you look at a fraction with this being x, sorry, not x number of times, a number of times of x, and this here being b number of times, there's a certain amount of these that are going to reduce. And it depends on how many are in the numerator and how many are in the denominator. But any that we have one in the numerator and one in the denominator, those will all reduce. We don't know actually how many times it reduces, but it keeps lowering how many x's are in the numerator and how many are in the denominator. So what comes out at the end is that we can have x to the power of a minus b times. It's kind of like if you had x to the third over x squared. Those would reduce 2 times, which would leave you left over with just x to the first. Now, in a power to a power, we have x to the a all of these times. As a matter of fact, it's b occurrences of x to the a. We know from the product of powers that every time you multiply these powers together, x to the a times x to the a as x to the a plus a. And well, if you do it b times, you have to multiply those to count that many sets of a. So it's x to the ab power. When you have a power of a product, so we have x times y, the whole things to the power of a, we can go ahead and just say that it's this product a times. So that means we have x here a times and y here a times, and they're all being multiplied, which makes us able to group them together using the commutative property and get x to the a times y to the a. Now we can do pretty much the same thing when we're taking power of a quotient, is that this is how many times we have x over y multiplied by each other. It's a times. So that means that we have x in the numerator a times, and we have y in the denominator a times, which will give us our x to the a over y to the a. Now, important to note that all of these apply only when the base does not equal 0. The base equaling 0 would affect its application. One thing I also want to point out specifically is that x plus y to the 8th power, this is not x to the a plus y to the a, because it's x plus y times x plus y a ton of times. And you won't see that here because, well, it's a ton of distribution. And it would just take up a ton of time to do it, but it's something that you want to make sure not to try to simplify in this way, because it's not like the power distributes, is that that's how many times x is there and y is there in these situations, all multiplied by each other. X to the zeroth is 1. Anything to the power of 0 is 1. Because if you take anything, so let's say the a power x to the a divided by x to the a, well, that's something divided by itself. So we know it equals 1. But we also know that when we do the quotient of powers, you subtract the exponents. So x to the a minus a is equal to that 1, which would then be whatever we have to the 0th power is 1. With the negative exponents, I kind of want to look and think about a pattern here. X squared is x times x. Well, you go power down, x to the first is just x. It's how many times x is occurring there. Well, x to the 0th is 1. Each of these times we keep going down a power of 1x. And what happens here is we keep dividing by a factor of x. X squared divided by x divided by x is 1, and 1 divided by x is 1 over x. So the more that we have here, more division. If we go x to the negative second, we divide by x again, it's 1 over x squared, and further showing about how this pattern keeps taking place. With the rational exponents, x to the fraction a over b, well, we could separate that. That could be x to the 1 over b times a power. We learned in unit 6 that a 1 over b power, a fractional power, can also be written as a radical. But we can take these powers when the powers are multiplying, it's also a power to a power. So this is an x to the 1 over b to the power of a, and it's also x to the a to the power of 1 over b, because the order of multiplication doesn't matter. Whether this here is 1 over b, uh, whether this here is 1 over b or times a times 1 over b, that order doesn't have a significance here. All right, so we could simplify problems like this. Here we have a expression that's a product being taken to this power of 3. So it's 5 to the third times x to the third, 3x squared to the fourth, y cubed to the fourth. Here on the right-hand side, I normally like to work from the right to the left, but on the right-hand side, we have power to a power on both of these. This is x to the 8th, y to the 12th. The power to a power, we multiply the exponents. We're not going to multiply this 5 and 3, because 5 is not an exponent. 5 is a base. We only multiply exponents together. We never multiply the base times the exponent. This cubed is talking about how many times 5 is there. 5 to the third is 5 times 5 times 5, or 125. And so we have 375, x to the 11th, y to the 12th. In a problem like number 2, we could say that we have this quotient being taken to a power, so we could go do something like this. I wouldn't write this down, by the way. But the problem here is you have this 27 to the third, and nobody wants to do 27 to the third on paper or in their head by their own choosing. There's other ways to work here. What we could have done instead is we could reduce this fraction first. So we have 9 divided by 27. Normal numbers just reduce like normal numbers do. A fraction of 9/27 before, we always divided the numerator and denominator by 9, which here gives us 1/3. A to the fourth divided by a to the fifth is a to the 4 minus 5, or a to the negative first. And b cubed divided by b is b to the 3 minus 1, which is b squared. So now we have this all to the third power. So we have 1/3 being taken to the third, a to the negative first taken to the third, and b squared taken to the third. So you have 1/27th, a to the negative third, b to the sixth. And often we like to write these fractions without any negative exponents. So we end with our answer being b to the sixth divided by 27a to the third. Now, if we look at number 3, we have, we actually have something really nice over here. This entire thing is being taken to the power of 0, and anything to the power of 0 is 1. So we're multiplying this, whatever we get out of the left-hand portion, by 1. We have 7 squared, a to the fourth squared, b to the sixth squared. So we have 49, a to the eighth, b to the 12th. And since we're multiplying by 1, it's just what we have here.